All right, here we go. 2.4, last section, chapter 2. We're going to kind of put everything we've learned in the first 3 sections into actually doing some probability, finding some probabilities. This whole section, everything is dealing with equally likely outcomes. Right? In other words, it's not like we're sampling, like drawing things out without replacement. That would not be equally likely outcomes because the probability changes if I take something out. Okay, if I'm like drawing names out of a hat, probability of getting a name changes at each time. So not like that. So outcomes are they stay the same each stage, I guess you could say. Long story short, doing these probabilities, keep this in mind. All right, if it's equally likely outcomes, if I want to figure out the probability, all it is I count the elements in my specific event, and then I count my elements in the sample space, and I divide them. That's it. Okay. Now, sometimes it's hard to do that, but if you always keep that in mind, it's going to help you. Okay. So basically, what all this means here, if I have the probability of some event, as long as my outcomes are equally likely, my numerator is just the number of ways my event can happen, divided by the number of ways in my whole sample space. And we usually find those using like sometimes permutations, sometimes combinations, that kind of stuff. Okay? So keeping this in mind all day today, all right, for all the next 15 minutes. Okay, so like I said, everything is equally likely outcomes. I guess we'll talk about permutations, combinations, some partitions, some straight up multiplication, but the outcomes stay equally likely each time. Right, so like flipping coin, rolling dice, those kind of things. So example 1, I've got 5 coins, 2 dimes, 3 quarters. I'm drawing 2 coins simultaneously. I want the probability that both are quarters. So probability that both are quarters, that's telling me that's my event. So remembering, I want to find how many ways can my specific event happen. So in other words, drawing 2 quarters out of these 2 coins. And then my denominator is the number of total ways this can happen. So it doesn't matter the order these are drawn in, right? Like quarter 1, quarter 2 doesn't matter. So that tells me I'm going to use combinations here. So for my, let's start with the denominator. All the possible ways we can happen in my sample space. So I have 5 total coins. I'm picking 2 of them. All that is combinations going 5, 2. Okay, my numerator is my event that I'm looking at. In this case, both quarters. So I don't care about dimes now. So disregard dimes. I have 3 quarters, and I need to choose 2 of those. That's my numerator, and that's it. Okay, and we would just calculate that. So that ends up with, that's 3 over the chain. So 30% chance. All right, you can leave it as 3 out of 10. So that's first example. Second example, this one's a little different. We have a runner that's in 2 races, and they're both on an 8-lane track. They're assigned a lane each race. We're assuming that these are done randomly, even though that a lot of times they're not. But we'll assume they're random. What's the probability that the runner has lane 1 for at least 1 race? Okay, so it means they're in lane 1, either the first race or the second race or both races. So this is one where I would probably do 1 minus the probability that they're not in lane 1 for either race. So 1 minus the complement. Okay, why did I do 1? Well, probabilities all add to 1, right? So it's kind of like the last section when we did it at least. We did all the ways minus what we didn't want. Same thing, all the ways add to 1. So 1 minus what I don't want, so not lane 1. All right, so now I'm thinking, okay, so we have two races. They're not lane one in either race. So all this is just like how do you say, think of it as like a multi-stage experiment. So for race one, what's the probability of them not being in lane one? Is 7 out of 8, right? So that's happening, and then lane two or race two, probability of not being lane one is also 7 out of 8. If I do that, so I'm finding 1 minus basically not in lane one either race. What's left? Well, that's either being in lane one race or both races. Okay, and then it's just remembering adding, subtracting fractions. So 7/8 times 7/8 is going to be 49 over 64. So 1 minus that, so 64 over 64 minus 49 over 64, so 15 out of 64. It's a chance of them being in lane one at least one race. Okay. Take a look at some more here. Okay, so we've got 12-unit apartment building has 9 smoke alarms that pass inspection, 3 that don't pass. Okay, so 9 are good, 3 are bad. If we select 3 at random, what's the probability that they're all good, basically, that they all pass? So think about how many ways can my numerator happen here. In other words, I'm selecting 3 smoke alarms that pass. That's my numerator. My denominator is any 3. So for denominator, okay, I have 12 units, so 12 smoke alarms, and I'm selecting 3 of them. That's just all the ways we can select a smoke alarm, my sample space. Numerator is how many ways can my event happen. My event is getting all that pass inspection. All right, well, how many of those are there? There's 9, right? So I have 9 of those good ones to choose from, and I want to figure out how many ways I can select 3 of them. And there's my answer. And then you can calculate that if you want. We've got enough of that. You need to go through that whole thing. Okay. Again, how many ways can we select our 9 that work, or select from our 9 that work, divided by how many ways you can select from all of them that work. Right. Different example. Okay, so now I've got quality management team has 8 people, 5 are from customer service, 3 from data processing. 2 team members are selected at random to present the results of the team's work. What's the probability that 1 of them is from customer service and 1 from data processing? All right, so again, find how many ways we can have our event happen. So in other words, how many ways can we select where we have 1 from customer service, 1 from data processing, dividing by all the possible ways I can select 2 people. So I have 8 people to choose from, and I'm selecting 2. That's all my possible outcomes. That's my sample space. Numerator, I need 1 from customer service and 1 from data processing. So we're going to kind of do this separately here. All right. So if I want 1 person from customer service, I have 5 of them to choose from, and then I'm choosing 1. Okay. And so we're going to multiply that by selecting 1 from data processing. There's 3 from data processing. So I have 3 of those people in data processing, and I'm selecting 1 of them. And that's how we would do this problem. Okay. So anytime I'm selecting like 1 from one group or something, so say it was like 1 from customer service and 2 from data processing. So I'm selecting 3 total. Okay, if it was 1 from customer service, it would be this is 5-1. But if I did 2 from data processing, it'd be 3-2. And that would mean I'm selecting 3 total people, so my denominator would be 8-3. Okay? So those are the ones that start, I think, give people the most trouble. So we need to take a look at that one again, take a look at it. Let me know if you have questions on that. So now we've got, student must select 3 courses from a list of 7. List includes 4 humanities courses, 3 science courses. Make a random selection, probably that 3 humanities courses are chosen. So my sample space, I have 7 courses and I'm selecting 3. We'll pull that right off the bat. So 7, selecting 3. Okay, my numerator is what I want, my event. That's basically have all 3 of our courses chosen are humanities. So I had 4 total humanities courses, selecting 3. Okay. And just note what you're selecting in the numerator needs to match up with what's in the denominator. Okay. Okay, last example, probably the hardest one here. So I have AA, Ron, and Abby are members of a committee studying the effects of government regulation on business. The committee consists of 4 men and 3 women. So that's my group I'm choosing from. I have 4 men, 3 women. Then I'm picking a subcommittee of 3. Okay? That subcommittee has to have at least 1 woman. So basically my subcommittee could be 1 woman and 2 men, or it could be 2 women and 1 man. It says it cannot consist entirely of women, so we can't do one with all 3 women. All right, so those are what I'm looking at. What's probably that the subcommittee will include AA Ron. All right, and then we'll look at Abby here in a minute. So including AA Ron, again, think number in my event or number in my sample space. So in my sample space, so my denominator, we have to think about these things. So 1 woman and 2 men. So that's one way I can do it, and then 2 women and 1 man is my other way. So you're gonna have 2 separate things in our denominator here that we're gonna add together. So the first one, let's look at 1 woman, 2 men. So I have 3 women to choose from, and if I select 1, it's gonna be 3, 1. And then I'm going to multiply that by how many ways I can select 2 men. So I have 4 men to choose from, choosing 2. So that's 1 woman, 2 men. And then the other option is the 2 women, 1 man. So I have 3 women, choose 2 of them, times 4 men, choose 1 of them. 2 women, 1 man. That's my denominator. Those are all the ways we can make selections. Okay, the numerator, now it's going to be basically the same, except Aaron is part of the group that's selected. Okay, so if we think about the first part, the 1 woman, 2 men. So if Aaron's part of that group, all right, that means he's there. Okay, so he's selected. So I'm just going to put a little 1. There's 1 way to select Aaron. And then I've got 1 woman to select. That doesn't change. Now I only have 1 man to select because we're assuming that Aaron is a man. Okay, so I only have 1 man. I only have now 3 to choose from because I've taken Aaron out. So I have 3, 1 for the 1 man. So I have Aaron, I have my woman, and I have my 1 man. That gives me 2 men, 1 woman. And I also have, okay, if I select the 2 women and 1 man, well, Aaron is already the 1 man, so he's there. That's Aaron. Now I just need my 2 women. I've already got the 1 man. So my 2 women for each other. And that's how we would go through that. Okay? I should have chosen a different name for Abby, something like maybe Be Nice, but we'll go with Abby here. So I want to figure out probability will include Abby. It's very similar. My denominator does not change. Okay, that's still my same sample space. So all that needs to change is my numerator. It's going to be done kind of in a similar fashion. Now we just need to include Abby. So if I have one woman, that's Abby. She's the one woman. And I have two men. So it's just Abby, 1 times selecting my two men. And then if I have the two women and one man, Abby's one of them. That's Abby. Then I need to select one other woman, but I only now have 2 left to choose from since Abby's been chosen. And then I need to select one man. I still have 4 to choose from, and that's including Abby. So that is section 2.4. These problems here are, I think, by far the toughest to do. Just a lot going on. Honestly, I struggle with them some too. I have to sit and think about them usually when I see them. So don't worry if it's a little confusing right now. If you go back, take another look at it. Hopefully it'll start to make more sense. We can go over some more like this in class.